Alright, today's topic is 5-1, growth and decay. Today's date is today. Our objective today is going to be to define and apply integral exponents. So, I'm sure about this moment you guys are asking yourself, what does exponential growth look like? Well, what happens is you start off very slow and you grow slowly, and all of a sudden you go really fast. It starts getting larger at an exponential rate, hence the name exponential growth. Exponential decay is going to be very similar. You're going to start really high, it's going to go down like that. So, we've got a nice formula that'll help us deal with exponential growth. It's A of t equals A naught times 1 plus r all to the t power. Well, let's figure out what each of these mean. Right here is your ending amount. The A sub 0, or the A naught, is your starting point, or initial amount. Your R is your rate, and it needs to be a decimal. And T, you should be able to figure out what T is. It is time. So let's go ahead and work out our first problem. Suppose that a radioactive isotope decays so that the radioactivity present decreases by 15% per day. So I'm already thinking that R is 0.15. If 40 kilograms are present now, so that's my starting point, find the amount present 6 days from now. Well, T would be 6. And my initial amount was 40. So I want to go ahead and figure out my ending amount. I could also have put A of 6 equals 40, 1 plus, if this had been, oh wait, I almost made a mistake. That is decay. So if something is decaying, it's becoming less. So I need to be subtracting, decreases. And my time is 6. Make sure you follow order of operations here. 0.85 to the 6th. You need to put that into your calculator first. So 0.85 raised to the 6th power is like 0.377. So 4 times 0.377. Oops, making lots of mistakes. That's not 4, that should be 40. Is 15.08, and then around to 15.1 kilograms. So if that is decaying at a rate of 15% per day, in 6 days, I'm going to have 15.1 kilograms. All right, the second part of that question is asking, well, how much did I have 6 days ago? Well, 6 days ago, it's kind of like in the past. I'm going to think of that as a negative 6. So, again, I'm going to follow my order of operations. 0.85 raised to the negative 6 is like 2.65. and then I'm going to multiply that by 40. And I get 106. Again, I'm going to round it to the nearest tenth, 0.1 kilograms. Let's do another. So currently, a college has a tuition of $12,000 a year. The annual rate of increase is 7%. What will the tuition be in 30 years? So we know our T, we know rate, and we know our starting amount. We just need our ending amount. It's going to be 12,000. And this time it is increasing, so I am using a plus sign. 7% is 0.07, and it is in 30 years. Do my exponent first, 1.07 raised to the 30th power, and you get 7.61 times 12,000. So, about $91,347. Wow. All right, here I've got some exponent properties. These are rules that I am going to expect you to have memorized. Product, if you have the same base, add your exponents. Quotient, same base, subtract your exponents. Power of a power, you are going to multiply your exponents. Product to a power, whatever's on the outside of those parentheses has to be applied to everything inside the parentheses. That goes for numbers and variables. Zero exponent, anything to the zero power is always going to be 1. Negative exponent, we don't like negative exponents. Whenever you have a negative exponent, you're going to try and make it positive. So if it's in the numerator, it moves down into the denominator and becomes positive. If it's already in the denominator, it's going to move to the numerator and become positive. Make sure you know these rules. They will not be given to you on any tests or quizzes. Let's do some examples. Well, I have 2m squared times 2m cubed. The 2's are my coefficients, and you just multiply them like you normally would, so that's going to give me 4. My base is m, and I multiply, so you add your exponents. 2 plus 3 is 5. And that's going to be my final answer. Well, the next one, there's actually a couple different ways that you could go about doing this. I'm going to start by applying that -4 to everything on the inside of the parentheses. So I have 2 to the -4, x to the -8. I don't want to have negative exponents, so that is going to become, so right now it is in the numerator. I want to move it down to the denominator. When I move it down to the denominator, it becomes positive. 2 to the 4th is 16, x to the 8th. On the next one, this is a division problem. Well, the 3's are just going to cancel out. And I've got n to the 4th over n cubed. You're going to subtract those exponents. So 4 minus 3 is 1. That's just going to be n. On the next one, I can't do anything with my my coefficients because there's nothing to cancel, so I'm still going to call it 4 over 3. Now I'm going to look at my m's. I have 4 on top, 2 on the bottom. 4 minus 2 is 2, and it's going to stay there. N, now let's look at our n's. 3 minus 2 is 1, so n to the 1. On the p's, I notice I've got more of them down on the bottom. So I'm going to think of it almost like a contest. The bottom is going to win on this one. 4 minus 3 is 1, p to the 1. And this is going to be your final answer. All right. This one, definitely getting a little bit more difficult. I'm going to start by simplifying the numerator. Multiply your coefficients. 2 times 4 times 3 is 24. My base is x, and I have 2 plus 2 plus 1. And remember, right there is a 1. That's going to give me 5. And my y's, 4 plus 4 is 8. Now I can go ahead. It's already starting to look a little better. I'm going to go ahead. 24 over 3 is going to simplify to 8. Now I'm going to look at my x's. Looks like I have more of them on top, so I'm going to minus that negative 3. Be very careful of your signs here. 5 minus negative 3 is 8. Look at my y's. I'm going to have more y's on top, so it's going to stay on top. 8 minus 2 is 6. I have a 1 in my denominator. We don't typically write that, so I'm just going to rewrite it as 8x to the 8, y to the 6. Oops. There we go. All right, that is it. Enjoy it.